This video is on sets and notation. We have three sets. A is 1, 2, 3, B is 1, 2, 3, 4, 5, and set C is 4, 5, 6, 7. We're going to talk about these very specific words: the set, element, subset, universal set, complement, union, intersection, and empty set. We're going to talk about the definition. We're going to give an example based off of our sets up here. So the first word, set, has the symbol that are the two squiggle brackets. This begins the set, this ends the set. The definition of set is a collection of elements. An example of this, you can pick any of these sets up here. So I'm going to pick A. Set A is equal to, I'm going to start the squiggle bracket, and then it contains 1, 2, and 3. It does not contain anything else. The next word is element. An element, the symbol for element is that E, it's like a C with a line through it. It's element. An element is a piece of the set. So that means that any piece from any of these sets I can use as an element. So I can say that 1 is an element of set A. I can say 1 is an element of set A. I use a capital letter for set A. Now, understanding what an element is, you can also understand what not an element is. So I'm going to use another example. I can say that the number 4 is not an element. So I do the symbol for element and I put a slash through it, and I say that 4 is not an element of set A. So again, I use a capital A for set A. So that goes hand in hand, that 1 is an element of A, but 4 is not an element of A. The next word is subset. Now you can also use this as with the proper subset. The symbol for subset is the C with a equality line underneath it, and a proper subset is just the C part. Now you'll see me use this one more often just because it's I will just use these interchangeably, but most of the time I'll end up just using this one. So a subset is when you're dealing with two sets. It's when you're dealing with two sets, and it states that all elements, so all elements of the first are in the second set. So all elements of the first set are inside the second set. Now this one states that the elements of the first are in the second set and there's nothing extra. This one states that all the elements of the first are in the second, but the second one has extra. This is one of the reasons why I'm going to use this one more often. So if you look at set A includes 1, 2, 3, and B also includes 1, 2, 3. So A is a subset of B. It's technically called a proper subset because there are extra things in B. So I can put that A is a subset of B because all of A is inside of B. There's just extra in B, and that's fine. So on that same hand, I can then also say not a subset. So if we look at B, we can say this has 1, 2, 3, 4, 5. All of set B is not in set C. It has part of it, but not all of it. So we can say that B is not a subset. So you put the subset symbol with the slash through it, and then it's not a subset of C. So set C, because all of B is not in set C. The next one is the universal set, which is a U, but with the lines on top of the U part. Universal set is talking about all the universe, it talks about everything. So it is, a universal set is the set of all possible elements. Now that doesn't mean every single number in the world. It's based off of the information you're given. So I have 3 sets up here, sets A, B, and C. So the universal set is a set of all of these possible elements. You do not write any of the numbers twice. So notice that we have a 1 in A and B. We only have to write it once. So we would write out that the universal set, so that U equals, since it's a set, we have to open up that squiggle bracket. And now we're going to write all the words that are a part of these sets. So 1, 2, 3 are in set A. 1, 2, 3, we don't have to write that again. But 4 and then 5 are in set B. Then we see 4, 5, which we've already said. Then we have 6 and 7. So the number 1 is a part of it. 2, 3, 4, 5, 6, and 7. Nothing after 7 is in that set, but we've written out all the numbers that are up here without repeating any of them. So universal set is everything from all the ones that we have. The universal set is all of the elements that we don't have to repeat. Complement. Complement is the elements that are not in the set. So if I'm going to be very specific here. I'm going to say A complement, or I can do almost A prime almost. Because I put an A here, that means I'm specifically talking about set A. I could say B complement, and that means I'm talking about set B. This is from the universal set, so I'm going to put from the universal set. From the universal set, these are all of the elements not in set, and I'm going to put quotes around A because that's the set we're talking about. If this had been a B here, I would have put not in set B. If this had been C, I would have put not in set C. So from the universal set, here's our universal set that we had right above it. I want all the elements not in set A. So 1, 2, and 3 are part of A. So I want to take out those 1, 2, and 3. So I would say A complement is equal to, since this is a set, you open up the brackets. I don't want the 1, 2, or 3. So that means we have to have the 4, 5, 6, and 7. 4, 5, 6, and 7. That's the complement. The union is very similar to the universal set. It's also a U. Well, this time you only really talk about 2 sets. So I'm just going to use A union B. The union does not have the lines on top of it because I'm not talking about all of the sets. I'm just talking about 2. So since I said A, then the B, a union is all elements in set A or set B. Since I used A, then B. So we'd use A, then B. Or, that means that if it's in A, I can write it down. If it's in B, I can write it down. But I still don't do I don't write the repeating numbers. It's very similar to a universal set. If I can write it, I'm going to write it. So we would say A union B equals. We're going to have the squiggle bracket. So I can write out for A, I can write out any number that's in A. 1, 2, 3. 1, 2, 3. Then I can write out anything that's in B. I don't want to have to repeat them. So I don't have to write out the 1 or the 2 or the 3 again. So we can write out the 4 and the 5. And that's the union of A and B. So A union B. We find everything that's in A, we write it down. Everything in B, we write it down. The intersection is when we want where they overlap. So if I use set B, intersect set C. So I'm going to use the symbol for intersect is that in, intersect. So this is all elements in set B and set C. I use B and C because I use B and C here. So I want to find the elements that are in B and also in set C. So if I go to set B and C, 1 is not in C. 2 is not in C. 3 is not in C. 4 is. So I can say that B intersects C is equal to square bracket. I find the overlap. We can see a 4. Then we have 5. 5 is in set C. So 4, 5. Now I have run out of set B, so anything else in set C definitely will not be in B. So that means I can stop it. You just have to use one set. So if I start with B, I check to see if B is also in C. Once I run out, I know that nothing else could be a part of it, so I can close my bracket. So the intersection is another word for an overlap. We want the overlap of our elements. Now the empty set, the symbol for that is that circle with a slash through it, or just open 2 brackets, same thing with the set, but this tells me that there's nothing in it. So this means that the set doesn't contain elements. That means that it's a null set. It's a null set. So this happens a lot when you're dealing with intersections, because intersections are when they overlap. What if there are no overlap? So if we look at set A, we have 1, 2, 3. It overlaps with B, but it does not overlap with C. 1, 2, and 3 are not in set C. So if I talk about A intersect C, there is no 1, there is no 2, there is no 3. And that's the end of A, so that tells me that nothing else can work. So there is no overlap. Therefore, that is the empty set or the null set. A intersect C is equal to the null set or empty set. Another word for this is that A intersect C is disjoint. Disjoint means that there's nothing inside the set. These are the words that we will mainly focus on in this level of math. We're going to do 2 examples down here that are just true or false. K is the set of whole numbers greater than 15 and less than 21. So if we write out what K is, so K is the set of the whole numbers greater than 15. So the first number greater than 15 is 16, 17, 18, 19, 20. And it says less than 21, so we cannot include 21. So we end that. True or false? 12 is an element of K. 12 is not a part of this set, so that it would be a false. So we would write out that 12 is not an element of K. The next one says that J is the set of months that begin with M. So J is equal to the set of months that begin with M. So we have January, February, March, April, May, June, July, August, September, October, November, December. That would be it. That's all of the months. So we can end our bracket, our set. True or false? March is an element of set J. J, March is in it. So we would say true. This example is understanding how Venn diagrams work, because that's the next part of this. Suppose that A is set of 0, 2, 3, 4, 7, and 10. And B is set of 0, 3, and 10. Write the universal set. So the universal set, we write out with the U with the lines on top of it, is equal to. We're going to start with the numbers. The smallest number is 0. It's in both of them, so we don't have to write it twice. Then we look for the number 1. Is in neither of them. The next number is 2. The next number is 3, which is in both of them. We only have to write it once. 4. 5 is not in them. 6 is not. 7 is in one of them, so we can write it. 8 is not. 9 is not. 10 is in both of them. And that is the end of both of them. So our universal set is 0, 2, 3, 4, 7, 10. We go in order. Now, if we write those inside of our Venn diagram, set B is 0, 3, and 10. Now, if you notice that the circle for B is actually sitting inside of A, because the 0, 3, and 10 are actually in set A. This means that B completely goes inside of A. So when I write out the set of A, I don't have to write out all the numbers of A, because again, I don't want to have to overlap any of them. So for part A, for set A, I want to include the numbers that aren't already written, because all of B is inside of A. So the first number of 0 is already inside of A, because if I were to take out this line, this circle part, if I actually widened that part out, I will still see the number 0 inside of the big circle of A. So I already have the 0. I do not have the 2 written, so I can write 2. We already have the 3 written. We do not have the 4 written, so we can write the 4 in part A. And then 7 is not written, but 10 is. So set A includes all of these numbers because set B is inside of set A, because it is completely inside of it. It's kind of like an egg. But in pink right here, I have 2, 4, 7 because those 3 numbers are only a part of set A. So that's why they're not inside of this circle with B, because these 3 numbers are only a part of A. But these 3 blue numbers are actually in both of these sets, so they're inside of each other. And then on the outside, this is a universal set. This is everything. So there are no other numbers on here besides these 6 numbers, and they've already been written on here. But let's say that the number 5 was another number that could be written. It would be written outside of the 2 circles inside the rest of the box. This question says, what is B complement? That little symbol up there is almost like a prime, is B complement. That's asking for what are the elements that are not in set B. B complement not in set B. So B complement. So if this is set B, we want to take out these 3 numbers from the universal set. We take out the 0, the 3, and the 10. And we're left with a 2, 4, and 7. That is B complement. Question B says, state whether B is a subset of A. That's asking, is all of B inside of A? So all 3 of these numbers are inside of set A. That means that it is a subset. So we would say yes, because all of B is inside of A. All of set B is inside of set A. So that's how we know that this is a subset. And you can see that all of this circle is inside of the circle of A. Another type of Venn diagram that you'll see, it'll show 2 circles overlapping, but not completely. That means that they wouldn't be a subset. They would just overlap each other.